Now let's try to analyze in a generic form. Let's try to derive a kind of formula. So before going ahead, we know that branches are of two types. One is a conditional branch and other is unconditional branch. And in case of unconditional branch, what happens is it is simply like a statement jump to certain instruction. So in case of unconditional branch, definitely there will be a non-consecutive instruction execution, and so every unconditional branch will lead to certain penalty. There is no way we can escape it, right? If the branch is unconditional, it means that definitely we should go to a different address, and whatever instructions that you have fetched till then, they all have to be flushed, right? Therefore penalty is going to be definitely present here. But compared to conditional branches, the advantage with unconditional branches, once we decode the instruction, we can find out that it is an unconditional branch, and even without executing, we can directly say what the target instruction is. For example, if there is an instruction like jump to address 200, assume that 200 is an address, some kind of address, then during the decode phase, if we can find out that it is an unconditional branch, then in the decode phase itself we can say what the next address is. Therefore, if you have instruction fetch and instruction decode, if you are able to find out in the decode phase itself that the next address is 200, then here itself we can fetch the correct instruction. Therefore the penalty is going to be less, which means in case of unconditional branches, penalty is going to be there, but then the penalty is going to be less. But in case of conditional branches, it is different. What happens is sometimes the condition may be true and sometimes the condition may be false. In case where the condition is true, then only we might have to flush the pipeline, and that is where we are going to get the penalties, right? Which means if you say jump if 0 200, and if the 0 flag is 1, then the condition is 1. If the 0 flag is 0, then the condition is 0, right? So then what happens is, see, if you want to understand it in a C programming kind of manner, if there is a condition like this, if A is greater than B, then you go to 2000, right? Otherwise you continue with the same execution. Then what happens? Then unless you execute it, you don't know what the target instruction is. Either it can be 200 or the consecutive instruction in the sequence, right? So in case if it is true, let us say you have fetched the instruction and decoded it and found out that it is a branch instruction, and only after you execute it you will find out what the condition is. Then only at this phase, let us say that is write back also, at this phase you will be able to know that the next instruction is so and so. Let us say this is 100 and you have fetched out the instruction 101, then you are continuing with the instruction 101, isn't it? Fetch, decode, execute, write back, and then you will find out 102, then you'll again fetch it, let's not go till this point, you'll again fetch it, right? Then at this point, exactly at this point, after the execution of the first instruction, you will know that the target address is 200, not 101. Then these two have to be flushed, then only you are going to get the penalty, right? So which means these 3 clocks you are going to get only one instruction. So penalty, how much ever the penalty is, we are going to face the penalty only when the condition is true. If the condition is false, then of course even after this execution stage also you'll find out that the next instruction is 101 and next one is 102, and they have already been fetched and they are in under execution. Therefore there is no penalty at all. Got it? Therefore the clocks per instruction will not be 1 only for certain type of instructions. What are they? One is unconditional branches. So whenever there is no condition, definitely branch, definitely the clocks per instruction for that is going to be greater than 1. And what are the other instructions? If it is a conditional instruction and if the condition happens to be true, only for those instructions the clocks per instruction is not going to be 1, it is going to be more than 1. And what is the other type of instruction? If it is a conditional instruction and if the condition evaluates to be false, in this case if the condition evaluates to be false, there is no penalty at all, because anyway our pipeline is going to get the next instruction and continue its execution, and only when we know about it that it is wrong, then only it is going to flush. If that kind of solution is being used, then there will be no penalty at all in this case, right? So under such circumstances, let's try to analyze what happens in a. So I hope you understood this, right? Now in my derivation I am going to set some assumptions, and based on that assumptions I want to derive certain formulas. Okay, don't by heart those formulas, just try to understand how we are trying to derive it. It will be useful when you are solving the questions. So assume that there are n number of instructions in a program and we want to execute all these instructions, and with a probability p, there is a probability p that an instruction is a conditional instruction, and we don't have any unconditional instructions here. We are not talking about unconditional, only conditional instructions we are talking about it. So totally there are n instructions, and p is the probability that an instruction is going to be conditional, and in case if an instruction is conditional, then q is the probability with which the condition evaluates to be true, and the target instruction is a different instruction and it is not going to be consecutive instruction, which means only with the probability q that the given instruction, which is conditional instruction, is going to be true, right? And assume that our pipeline is having m stages, and we will be able to find out the target instruction address only at the end of m cycles. Are you getting this? So totally we have n number of instructions, and the probability that a given instruction is conditional branch instruction is p. Given that the instruction is conditional branch instruction, the probability that the condition evaluates to be true and there has to be a branching is q. And assume that m is the total number of stages in the pipeline, and the only after all the m stages are over, you will be able to find out that the target instruction address. You will be able to find out the target address instruction. Then under these circumstances, what is the average or effective? Sometimes they will say effective clocks per instruction. In general, if there are no branching at all, if there is no control dependency, the clocks per instruction has to be 1. But because of all this, it has to be more than that. Let's try to analyze it. Now, if the total number of instructions are n, then probability that an instruction is going to be conditional branch instruction is p. Then what is the total number of conditional branch instructions? Total number of conditional branch instructions equal to n into p. So if you want to understand it numerically, let us say there are 100 instructions and 0.1 is the probability with which an instruction can be conditional branch instruction. Then how many conditional branch instructions will be there? You multiply them, which is nothing but 10. That is what I am writing here. Got it? The total number of conditional branch instructions is n into p. Now, if this is the total number of conditional branch instructions, how many conditional branch instructions will lead to a branch? They will lead to a branch only when the condition happens to be true. And when will the condition happen to be true? The probability is q, right? Therefore, the total instructions which branch is going to be n into p into q. Got it? And now for all these instructions, if you execute them together, how many instructions or what is the number of clocks that will take for each instruction? We know that for an M stage pipeline, if they are saying that one instruction is going to be executed, the target address is known only after M cycles, then it means that all the M stages have to be completed, then only we are going to start the next one, Therefore, for all these instructions for which conditional branching is going to happen or branching is going to happen, the number of cycles required for them is M. So total number of, are you following it? The total number of branching will happen for these many instructions. Then what is the total instructions which will not branch? So out of n, the instructions which will branch is n into p into q. Therefore the instructions which will not branch is n minus n into p into q, right? So which is nothing but n into 1 minus pq. So this is the total number of instructions which will not branch. Got it? And they are giving that the number of the target instruction will be known in case of this branching only at the end of all the M stages. Then how many cycles will it take for us to complete this each instruction here? The number of cycles for these instructions will be M, and for the remaining instructions anyway always it is clocks per instruction is going to be 1. Got it? Therefore, if you understand this, the instructions are now classified as two types. One is the instructions which will lead to branching, and other is the instruction which will lead to no branching. And the number of instructions which will lead to branching is n into p into q, and the number of branches which will lead to no branching is n into 1 minus pq, right? And for the branching instructions, they are saying that only at the end of M stages we will be able to find out what the target address is. Therefore, the number of clocks required for these instructions is M, and the number of clocks required for these instructions is 1. Got it? So this is the total number of clocks required to execute all the n instructions under the given condition. Then divide it with total number of instructions, then you are going to get average clocks per instruction. This is the total number of clocks required. If I divide by n, I am going to get average clocks per instruction or effective clocks per instruction. Then you will see that the effective clocks per instruction is going to be m into pq plus 1 minus pq. One other way of writing this is 1 plus 1 plus pq into m minus 1, right? So what does it mean? Normally we take one clock per instruction. The clocks per instruction is going to be 1, but because of the branching we are going to get this, right? Okay, so now if you observe this, you can learn various things here. If the number of conditional branch statements increase, then of course the clocks per instruction as a whole will increase, right? Or if the number of branching instructions increase, then of course there is going to increase. Or you can also see that if the number of stages increase. So what does M here mean? Here M represents the number of stages after which the target address will be known. If the number of stages taken to find out the target address is high, then of course the penalty is going to be high, and so the clocks per instruction is going to be high. So in exam they might mix various things here. They might say that there are 1000 instructions, out of which certain percentage of instructions are conditional branches, and in case of conditional branches, after 2 stages they will give all this. After 2 stages you are able to find out the target address instruction, and then they will say that certain percentage of instructions are unconditional, and in the unconditional instructions certain percentage of instructions are true and certain percentage of instructions are false. And they will say that this percentage of whenever the condition is false there is no penalty, and whenever condition is true they will say that you will be able to find out the instruction address, target instruction address, after let us say three stages. Then they will ask you what is the average. So it is just a kind of application of this concept. If you understood whatever I discussed here, you will be very easily be able to solve any question. Okay, so let's try to solve some questions and then we will discuss further.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.